Proportion can be used to scale things up or down. There are two types of proportion. There's direct proportion and there's inverse proportion. Okay? Common in the exam, this one. Okay? But fairly straightforward to do. Let's look at some direct proportion. So here's Adam, and he wants to make some cakes. So he's got this recipe from his gran, but it's for 12 cakes. It's 150 grams of flour, 75 grams of sugar, 75 grams of margarine, and 3 eggs. That makes 12 cakes. But Adam wants to make 20 cakes. Okay? So he rings his gran up and he says to his gran, "Gran, you've given me this recipe for 12 cakes, but I only want to make 20 cakes. What should I do?" And she says, "Well, just double the recipe and make 24 cakes." No, he says, "I don't want to do that. I just want to make 20. I don't want to make 24. So how am I going to work it out? How can I work that out?" Well, it's dead straightforward, isn't it? It's all about finding out what one portion is worth. So for 12 cakes, he needs 150 grams of flour. How much would he need for one cake? Well, 150 divided by 12 gives us, anybody?
12.5.
So for one cake he needs 12.5. So now he knows what he needs for one cake, he can make as many cakes as he wants, because all you've got to do now for 20 cakes is times that by 20. 250. Yeah, that's as straightforward as it is. For sugar, you need 75 grams for 12 cakes. What we're going to do with that? Divide it by 12 for one cake, which gives us, anybody? 6.25. Times it by 20 for 20 cakes.
125.
We've got it. Margarine's the same, thankfully. We don't have to redo it. So that's 125 grams of that. Eggs, he needs 3 eggs for 12 cakes. So for one cake, he will need a quarter of an egg. 0.25, quarter of an egg. But luckily he's making 20. So how many eggs does he need?
5.
5 eggs. And that's it. That is what proportion is all about. It's exactly the same as ratio. It's finding out what one part is worth. Once you know what one part is worth, Adam can make as many cakes as he wants. He can make 30 cakes. He could make 40. He could make 120. Because as long as he knows what he needs for one part, he can just multiply it to make as many cakes as he wants. Yeah? Does that make sense? It's relatively straightforward, isn't it? So it's all about finding out what one part is worth. Okay. Antonia has a recipe for a fruit drink using the ingredients shown below. She wants to make a big batch of the drink. Assuming the ingredients remain in proportion, how much of the drink can she make if she uses 1,100 millilitres of lemonade? Okay, so lemonade comes in a 200 millilitre bottle. Okay, she's using 1,100 millilitres of lemonade. So how much can she make altogether? Okay. That's a bit of a tricky wordy thing, isn't it? That's a trickily wordy thing. Draw yourself a picture if you need to draw yourself a picture.
Is it just asking asking how many bottles she can make, or how
How much of the drink? So how many millilitres or
how many
litres of
millilitres
drink?
in
Yeah.
total.
In
Right,
total.
Okay.
Yeah.
Okay.
And she's using 1100 millilitres of lemonade. So, my pen's running out, so I can't really draw the picture really. Well, there you go. So, lemonade comes in 200 millilitre bottles, or 200 millilitres is the ingredient, it's one part of the drink. So she's using 1100 millilitres of lemonade, yeah? So she's using 1, 2, 3, 4, 5, 5.5 parts of lemonade, yeah? That's 1100. 5.5 parts of lemonade. Call it 5.5, because it's obviously going to be going in your calculator. So 5.5 parts of lemonade. You see where that's come from? So that means she needs to use, because proportion, 5.5 parts of lemonade of orange juice. So orange, 150 is 1 part, and she's using 5.5, so she has to use 5.5 pints of that. Cranberry juice, 1 part is 80. So she's got to use 5.5 parts of that, because everything's in proportion. Yeah, so we know she's using 1100 lemonade. Let's put that on the top to start with. So what's 150 times 5.5?
8.
What is 80 times 5.5? 440.
That's what the calculator said.
Yeah, cool.
How much of the drink can she make?
2, 3, 6, 5.
We add all them together, which gives us
2, 3, 6, 5.
2,365 millilitres of drink. Let's see if we're right. Boom, yeah we are. I did it the kind of pictorial way there. 1100 divided by 200, because we know that that's what the one portion of lemonade is, it's 200. And she used 1100, which meant she used 5.5 cartons, which was 5.5. Proportion's the same, so we take the orange juice, 150, times it by 5.5. We take the cranberry, is 80 ml, you times it by 5.5, gives you the 440 ml, and you add them all together. Doesn't that make some kind of sense? Yeah? Same style of question, it's just worded slightly differently. Okay? These are not really dead common in the exam. What I find more difficult about these is the wording of the question rather than the actual sums. The sums are quite easy. But all I want you to think about when you think about these is thinking of the information you've got. 1100 millilitres of lemonade. And lemonade, 1 part is 200. So how many parts of lemonade has she actually used? Once you've found that bit, then you can apply it to these next 2 parts, because everything's in proportion. Everything's in proportion. They're not dead common, thankfully. What are common are these kind of questions. Okay? This is the inverse proportion. This is as one number goes down, another number comes up. Or as one number comes up, another number comes down. It's doing the opposite of it, each on each side. You'll have seen these kind of questions. It takes 3 people 4 days to paint a fence. How long is it going to take 6 people? So what happens here is, that number's doubled. 3 times 2 is 6. So on the opposite side, on the inverse side, that number is halved. 4 divided by 2 is 6. If you get 12 people, that's double the amount of people, so it's half the amount of time, doing the opposite to it, yeah? You're multiplying on this side, you're dividing on that side. Makes sense? But then you did have 12 people. Suddenly, 10 of them have disappeared. You've now only got 2 people left. What's happened? That number has been divided by 6. So on this side, you've got to do the inverse, which is the opposite. So you've got to multiply by 6. So from 1 day, it goes to 6 days. Does that make sense? Yeah? If you're times in, then you divide your half. If you're dividing, then you times. You're doing the opposite. Yeah? That's what this means in a nutshell. Kind of question you're going to get in an exam. You're going to get something that looks a bit like this. If it takes 3 builders 5 hours to build a brick wall, how long will it take 2 builders? Now this is slightly different because these numbers are a little bit different. We've got 3 and 2. Rather than 3 and 6, we've got 3 and 2. So, this is a bit tricky. This is the easiest calculation you'll ever do in maths, believe me. You take the information that you already know. We already know that it takes 3 builders 5 hours, and you multiply 3 times 5, 15. You then take that answer and you divide it by the other number that's in the question, which is 2. 15 divided by 2 is 7.5. It's going to take 2 builders 7.5, 7.5 days. The easiest sum you will ever do. Multiply the 3 by the 5, 15. Divide the 15 by 2, 7.5. So it will take 2 builders 7.5 hours. We know we're right because we're a builder less. It's going to take a bit longer. Just remember that formula, you'll never get these wrong. In the exam, this will be a question about somebody building a stage or putting a tent up or painting some walls, yeah? And the numbers will be, they might be a lot bigger. They might be massive, some of the numbers. But the formula, the method is exactly the same. Multiply what you know and then divide it by what it's asking you. Okay? Should we practice this? Here we go. It takes 8 workers 25 months to build 10 houses. Assuming they all work at the same rate, how long would it take 20 workers to build the same number of houses? Multiply the information we already know. Divide it by the information it's asking us. So what's our first sum?
8 times 5.
8 times 25, which is 200. What's the second part of the sum then?
200 divided by... No.
Yeah, keep going.
20.
200 divided by 20. Yeah, which gives us an answer of 10 months. 10 months. And we know we're right. Why do we know we're right? Because we've got more workers, so the time is going to decrease. We've got 20 workers where we did have 8. We've got 20. So the time's going to come down. It's come down from 25 months to 10 months. Just remember that, and you will never ever get these wrong. Okay? Multiply what we know, divide by what it's asking. Yeah? That 10's irrelevant. Divide by what it's actually asking. So far, so good. Let's try a couple more. Anya walked 4 kilometres in 52 minutes. How long will it take her to walk 6 kilometres? Think about the cakes with that one, rather than thinking about what we've just learned. Think about the cakes. Find out how long is it going to take her to walk 1 kilometre. Yeah? It's more like direct proportion question, that one. How long is it going to take her to walk 1 kilometre? Once you've got that, she can walk as far as she wants. We'll just do that first one, Anya, first, and then we'll do the answer, and then we'll look at the second one, because the second one is the inverse one, the one we've just looked at. Got an answer? Got an answer? So what did we do? Let's see where we worked it out. We had to find out how long it took her to walk 1 kilometre, didn't we? So how did we do that?
52 divided by 4.
52 divided by 4, yeah? Which gives us 13. So we know that she can walk 1 kilometre in 13 minutes. Once we know that, walk as far as she wants. So how far? 6 kilometres, how long does it take her? 78 minutes. Yeah? So far so good. What about this second one then? It takes 1 hour for 3 gardeners to cut the grass of a football pitch. How long would it take for 5 gardeners to cut the grass? I'll give you a little tip here, and you don't end up with a decimal number. Change that hour to minutes. Change that hour to minutes. This is the second one, the one we've just learned about, the builders building the houses, the builders painting the wall. Yeah? What have we got? What have we got? What do we do with these numbers? Same that to minutes we did, didn't we?
60, yeah.
60
Times 3,
equals,
180.
divided by
5,
equals
36.
36. What are we worried about? Let's do the exam next week. Fairly simple, fairly straightforward. Yeah, fairly easy to do. Distinguish between the two.
Yeah, I was going to say that.
There is a
You need to
distinguish
know
between the
which
two.
one to do.
Yeah, to know between, and it's going to be the way that they're worded. Yeah, these kind of questions are always going to be about somebody driving so far in so many minutes down the motorway. It's kind of like a speed, distance, and time question. But that's what they're always going to be concerned with, things like that, or having a recipe for 10 cakes, needing to make 14 cakes, that kind of stuff. That's how them kind of questions are going to be worded. These kind of questions will all sound exactly the same as this, because you can't make that sound any different. No matter whether it's building a wall, putting a tent up, painting a fence, they're all going to sound exactly the same. Okay? So get used to looking at the two different questions, how that one looks and sounds, and how that one looks and sounds. And they look and sound different, and that's how you would distinguish between the two. And this one's always all about finding out what one part is worth, and this one is just that dead simple calculation. Multiply them, divide by that. Okay? Multiply them, divide by that. If you remember, they're always worth about 3 marks in the exam. I can't believe it, because it's one of the easiest calculations you'll ever do. But just read and look and think to yourself, right, that's that kind of question, that's that style of question, that's that style of question. All to do with proportion, but different ways. This one's finding out what one part is worth, this one's slightly different. Okay, this one's slightly different. And that's basically ratio and proportion. We've not touched on scale. I don't know if we've got time for scale. 25 to. I don't really want to rush through scale, so we'll have a look at it next week.